This live stream always ends after 10 minutes. Hold up, there's issues right now.
See here.
Wait, did we get you on?
I think so. Can you
Oh
hear
my
me?
god, thank you so much for joining. This is insane. Here, hold up. Okay. I'm doing a lot of crazy things today. I'm also trying to did I disappear? Can you hear me?
I can hear you.
Okay, but my weird. For now it's okay. No one needs to look at my face. We'll just talk to you. Oh, there we go.
Okay. I can maximize it. I thought I was just looking at my own view. Okay.
Oh, okay. So you hid me. Cool. No problem. I gave you a lot of permissions, but that's fine. Cool. Hey guys, thanks everyone for joining. Thank you for your patience. I know we got started pretty late, but just trying to figure out, the restream stuff. This is our third episode, so the fourth one will hopefully be better. It's an iterative improvement. But yeah, I guess we can get started. I'll just share my screen really quick to go over the agenda and then we can kind of hop in. So today we have Michael Llewellyn from OpenZeppelin. We're going to start off by just talking upgrade security with him. He has a lot of really interesting things to say. I talked to him for a bit yesterday and I was like, this man is big brain. So I'm really excited. And then leave some time for Q&A about that. And then, as always, the second part of it is we'll actually build one together. We'll start off with a V1 contract, use OpenZeppelin's upgrade plugin to easily transfer over to V2, write some tests, and then also, again, leave some Q&A and say a big thank you to everybody. So yeah, let's actually get started talking to our lovely guest. Cool. I guess we could get started with, hey, Michael, you want to give us a little bit about your background?
I've been working in the blockchain space for a good while, probably going on 10 years now. Started out, doing the usual Bitcoin mining and crypto wallet thing. Started out as a general consultant because no one else in Dallas knew how to do that because I'm based here in Texas. And then eventually over time, like when Ethereum came out, I was really excited. I was getting my computer science degree, so I started to do more work on that. And then eventually Over time, did a lot of consulting on different projects. I actually came out to TruffleCon a few times and taught about doing testing and things like that. And then eventually, around 2021, I joined OpenZeppelin. Worked a lot with our security audit team, where upgrades come up quite a bit. Upgradability is also something we have a part of our core library and tooling, which we can talk about more later. But and then eventually I moved into a new role where I'm head of solutions architecture, which basically just means I help clients learn what are all the different kinds of security solutions they can build with OpenZeppelin products and services, and just offer general security advice. And I'll work with a lot of our big clients like Aave, Uniswap, and Compound, and even working directly with DAOs in some cases.
Okay, very cool. So we have a wide range of expertise in terms of our audience. So maybe we could start with the very basics. Like, what exactly is a smart contract upgrade?
All right. So I guess in the beginning, we had this vision of smart contracts for Ethereum that was typically based on a concept of immutability. That is to say, blockchains are immutable. You can't change data once you've uploaded it or uploaded a smart contract in this case. And that's considered good for, it can never be altered by someone maliciously or things like that. But then, in the early stages, as time went on, people realized, hey, if I deploy a smart contract and then I need to make changes to it or features, or I need to fix bugs, the only alternative people really had is to do a migration to say, hey, I deployed a new version, everyone move over to that. But if you have a bunch of tokens, or maybe even have like a DeFi market, like that's very difficult to do, especially if these are changes that might happen frequently, or the bug fixes are urgent. So this concept of upgradability was talked about very early, and then over time, patterns started to develop, most notably things like the proxy pattern and others, where it's like, hey, we can build smart contracts to have this ability to upgrade through other means, usually by having some way to kind of like replace logic in a smart contract with by separating them into different components or things like that. But in essence, it just means we can in some way change the code within a smart contract for different purposes.
Cool. I just want to kind of touch on something that you mentioned. It sounds like basically, if you want to write an upgradable smart contract, that is a decision you have to make from the start, right? Yeah.
Yes.
Okay. Cool. So keep that in mind, guys, when you're starting to build your dApps. It's kind of a go or nothing. Yeah, so I think also to that point, you had also kind of touched on what was happening before upgradability. You said migrations and things like that. So that's something I'd also actually like to talk about before we dive into the should we. Like, is there even what are the alternatives, right?
Yeah.
Um, is there a
Yeah.
way to avoid it?
I
Answer.
would say the only way to avoid it is to be very confident going into production. And there are some cases, like, if you're building an ERC20 token, it's going to be simple. You don't plan to put much functionality in there that isn't already standardized. Like, you might not need upgradability, and it does add some complexity and overhead. So if you can avoid it, that's nice. But there's definitely a lot of use cases where if you're not sure if you need it or not, it might be better to have it. And in those cases, in the future, you could even burn upgradable roles. You can say, you know what, we no
Mhm.
longer need to make this upgradable. We'll remove that permission. You can build that in from the start as well. Um, but I would say, yeah, unless you have a very clear, obvious use case that is simple, won't need to change in the future, that's where upgradability really becomes important. Because otherwise, yeah, you're essentially either going to have to just migrate to an entirely different smart contract, or you're just stuck with what you got.
Okay, very interesting. Okay, so actually let's get into the meat of the conversation, right? The should we. Um, you know, I think when you read about or think about upgradability, a lot of it is that trade-off between immutability and upgradability. So let's kind of start from, why is immutability important?
Gotcha. So mutability is really important because it's essentially a promise of the system. Whether that's Ethereum as a layer one blockchain, which we're all building on, or the smart contract itself. Like, are you setting expectations that this is not going to change or not? And in the case of a smart contract, if you are going to introduce upgradability, that's can be good for a lot of reasons, but it's something that you need to make clear up front and say, hey, it is upgradable. These are the ways it's controlled, and that's just important because like sometimes you're like, hey, I don't want to worry about someone deciding to make a change that's going to impact me. I want to rely on this, forever, as some people want to do for a blockchain. So it's just really important to understand that up front. Most people default to thinking things are immutable on a blockchain, but upgradable contracts do kind of break that guarantee to a certain extent, usually for good reasons, but it just needs to be well understood. There are still some people in the industry that consider upgradability a bug, so to speak, because you can potentially upgrade it and cause issues. So ultimately, the power relies on whoever controls that upgradability, whether it's a person, a multi-sig, a DAO, to just do so properly and responsibly.
Right, right. Yeah, so when I hear stuff like that, we talk a lot about what it's the, like, blockchain trilemma kind of stuff. So, immutability kind of what compromises the decentralization, like you mentioned, like someone's making that decision. Again, the trustlessness aspect, the reason we all love blockchain, things like that. But now that we know, immutability wise, like why is upgradability important then?
Gotcha. So I mentioned it already, just so
Yeah.
adding features and bugs, but I think most especially, like if we had to look at some core examples, we're building more complex systems, especially in DeFi. Like if we take Compound as an example, which I work with regularly, it's a lending market. It has many different tokens that are integrated into the protocol, and things change over time. Like as you are building these protocols, like you might be very early. Compound was one of the first to do a lot of things in the industry when it came to DeFi, and over time you learn what works and what doesn't. And some things that you might have thought would work in the beginning are actually not the ideal solution, and you don't really want to have to pigeonhole yourself into only being limited to a certain approach. And in some cases, it might make sense to just simply release a new version of the protocol and tell people migrate over to this. That's what Uniswap does, for example, with like V2 to V3. But there are still cases where, like, as part of this ecosystem, there are smaller changes or even bug fixes that will come up. And it's just not practical to migrate every time a small change occurs. And that's where upgradability becomes really useful. So I think really just because like development in general is iterative, and like development in the Web2 world is usually iterative as well. Like we're learning as we develop, and in many cases learning after it's been deployed, after it's in production, it's being it's being tested, or battle tested. There's going to be some things that come up that you just want to be able to resolve in the code where it sits, as opposed to just doing it somewhere else and starting from scratch. So I think that just really supporting the iterative process for developers to learn and improve.
Right. Yeah. I love that you say like there's been a lot of early players and we're learning from it and it's battle tested because I am an incredibly like non-committal person. So the idea that this is a decision I have to make from the start is like very scary. But obviously there are industry leaders who have been doing cool things and kind of developing the way we upgrade. So before actually I segue into like kind of the how people are doing it now, I think the last piece you had also touched upon is you mentioned something along the lines of like multi-sig wallets and DAOs and stuff like that, which I think probably plays a key role into the central, like trying to alleviate centralization, right?
Yep.
Yeah.
Yeah, it really comes down to who's controlling that role, and it's usually there's an upgrade role that usually like, you treat it like an only owner role. Like when you deploy the contract, someone set as the owner, and that owner might also have that upgrade privilege if it exists. You can also set it to be a different account through role-based access control. It's a library we have at OpenZeppelin, but regardless, someone controls that. And you can set it to be an individual account. And a lot of early stages for projects, there's not a large community. It's really kind of in almost the test beta phase. So it makes sense for one account to have that control. So you don't have a lot of overhead to be able to make changes if you need to. But then as the protocol grows, more people depend on it. You might want to essentially decentralize that control. You can start with a multi-sig and say, hey, we're going to bring in multiple parties, not just members of the founding team, but maybe community members that can be a part of the decision to make changes and help review them to ensure that they're, secure and trustworthy. And then eventually over time, you might even be able to delegate that functionality to a DAO, which can take many different forms. So the nice thing is that as long as you build in the ability to swap upgrade roles, which most upgradable libraries do already have that built in, you can essentially mature, you can change that role and that governance over time. And then maybe at some point you're like, you know what, we're feature complete. We haven't had a bug in a year or so. Well, let's just burn the upgrade role. And sometimes that's a decision for every project to make on their own, but you could get to that state where we don't need upgradability anymore, and we'll remove the ability for governance to make any changes. And some projects will never do that. Some might see it as a big part of their roadmap. It will just ultimately depend on the use case.
Yeah, yeah. I guess kind of when those decisions are being made, do you are there any kind of like mechanisms that we can think about for like users to kind of run away from this in a sense? You know what I mean?
Oh, you mean
Like
the red flags?
red flags, maybe like one part red flags, like how do I know whether or not this is safe? I think I was
Uh,
trying to also kind of think about like I had read something briefly about like time locks and escape
mm,
hatches and things like that. So maybe we could dive into both of those, starting with the
yes.
how to identify red flags, guys.
Gotcha. Yeah. So I mean, when I say red flags, I guess I mean like
Yeah.
if a protocol is not being very transparent with how upgrades
Mm,
work, or they're not, you can read the contract and see there's an upgrade rule, but they don't talk about it. That's kind of suspicious to me. I think being just upfront and transparent around this is how upgrades work. This is how we do. Excuse me. This is how we do it. This is the process. That's I think really important. And time locks are an additional step on that, which is to say if you're going to make a change to a contract, the team can put it through a time lock. So it basically means that every change is going to be frozen or like you could put it in for 2 days or a week, and just people have time to look on chain and see there's a change incoming. And if you're like putting your money in a protocol, you can decide if you want to remain a part of that protocol or pull your money out before the change occurs. So that's just a way to kind of give a commitment of allowing the community to review it, which ideally should even happen before it's been put on chain. But at the very least, certainly once it's going through to the smart contract, there's like a locked in change timeline. The only downside to that is if you're trying to fix a bug, then well, it might take a little longer. So there's trade-offs there that you just have to be aware of as a team. And then for like escape hatches, I think that's a similar thing of allowing users to exit the system even if it's paused or there's been some admin action on it. Like MakerDAO has an emergency shutdown where they can pause the system, but people can still move money out. So that's the idea of an escape hatch, which I think is both of these things can be used not just for upgrades, but for any governance decisions, DAOs, transfers, whatever. But certainly important for upgrades. And upgrades in general should be not just checked for is this doing what the community wants? Is this like, I guess trustworthy, but also is like, does this have not only potential bugs in it, which is where security audits and code reviews and testing comes in, but also like, is it compatible with the upgrades? So the way that upgrades work, and maybe this can be like we can get into more detail with your further questions, but you need to match certain conditions in order for it to be compatible with the system when you're upgrading a contract. Storage layouts and things like that is definitely something you want to check prior to actually deploying that upgrade.
cool. Yes, I definitely have extra questions later to talk about, what you had just mentioned. I did want to kind of interject one more thing that I was thinking about as you're talking. With this kind of publication or how do you call it? Making it public that upgrades
Proposal.
are happening. Yeah,
Yeah, public
proposals.
proposal. Yeah.
Public proposals. Yeah, yeah, yeah. Does that like add in any kind of like another security vulnerability in the sense that like I as an attacker am like, "Oh, like this is happening. This is the way it's being upgraded. Now I have this information about a security vulnerability that I can go in and I guess maliciously take advantage of now."
Yes.
Um,
Yeah.
right.
So yeah, it's absolutely a risk if you're needing to fix a bug in
Mhm.
production on the smart contract. But because you built in a time lock, it's always going to be limited.
Okay.
So yeah, that's definitely like it's a core trade-off that every team needs to be aware of. It's why some teams start out with upgradability without a time lock, not because they want to have more control than they need, but because they want to be able to respond to bugs quickly. So it's not to say that time locks will. There's a reason that it's a trade-off. It's a very difficult decision sometimes, but I think one of the ways that you could have a time lock without feeling like you're overexposing yourself is you could build in possibility to the protocol as well, which is where that escape hatch comes in, where you say, hey,
Mm,
if there is a bug, we're going to pause the protocol so that no one can potentially exploit this vulnerability while we're pushing through the patch that everyone has time to review. And there's an escape hatch in case people still don't agree with the change. They want to exit the protocol. There's one mechanism to do it and withdraw, but everything else is paused. And hopefully that has essentially stopped the vulnerability from being exploited.
I see. So is pausing kind of like for if we were taking like a real example, like stopping transfers from happening or something like that?
Yeah. If we're talking
So
about like a lending protocol, like no one can do market activity. They're not borrowing, they're not lending. The only thing in that case they can do is exit their position.
okay, cool. Awesome. So taking all of this into consideration now, I'm so well informed. Let's actually talk about into the how. How do we make this like how do we even do this? Right? Yeah, I guess just fire away. Maybe I think we had touched a bit on like proxy contracts and things like that. So I guess starting from like the very basic vocabulary, like what is proxy? Like, you know, in this case, how does this play into the patterns that we'll talk about moving forward?
Gotcha. So, like, I'll mention there's several other upgrade patterns out there, but proxies are by far the most common. And there's like a standard around the storage layout of that called EIP 1967 that we actually had a few OpenZeppelin folks contribute to. It got finalized this year. It's been a couple of years waiting for that. But basically, because again, by default and technically every smart contract is still immutable, what upgrades do is they kind of separate out the logic and the state in such a way that we can change things out. So basically, usually what you have is you have a proxy contract, which acts as a place where you store state, just the data of that smart contract. And it's also the entry point. It's where everyone will call. It's the same contract address for every function call. And then behind it, connected to it, is an implementation contract. And that's what is going to contain the logic and has the ability to be swapped out. So if you want to deploy a new implementation that has new logic, you can do so and then link it into the proxy contract so you don't have to worry about, the state is preserved to a user. They don't have to swap what address they're talking to. So it's as seamless as it can possibly be. And so that's typically what we're talking about a proxy contract. There's one contract that acts as an entry point, and there can be multiple implementations out there, with one of them being the most current that's being used by the proxy. And usually when we're talking about an upgrade, the implementation's been deployed, and the upgrade is just calling the proxy and say, use this new implementation. This is going to be the thing going forward with time locks and governance procedures around that if you want.
Okay, cool. So I guess to talk a little bit about that, does that mean the state and like the storage that is preserved is all stored in the proxy contract then? And that's how you kind of maintain information? Okay.
Exactly. And that's why there's actually a really important set of standards around this, because you do need to still keep that mapping. Like you can't just
Mhm.
deploy new implementation, I guess, willy-nilly. You have to make sure it matches up with the proxy and what states preserved in the proxy and what new implementation you're deploying. So that's why storage layouts are really important. And that's something that we have a tooling for that is compatible with Truffle, where you basically can, when you're using an upgrade contract through our library at OpenZeppelin, you can validate before you deploy it. Yes, this matches the storage layout. It's not going to cause any collisions or issues. You also have some like specific requirements, like you can't have constructors because instead of constructing it on initial deployment, you're actually going to have to link it in. So you initialize, you don't construct. And
Mhm.
there's a few other things you have to be aware of in terms of how the functions line up and how the state lines up. And that's something that can be very difficult to do manually for a
Right.
developer, which is why tooling is so important to kind of automate that process based on common standards.
Yeah, yeah. And I guess for the people who aren't super familiar with like the basic like technical stuff of like Ethereum. We keep talking about storage layouts, right? Because the way it executes is it cares about like what slot it's in almost, right? So having like you have to take into consideration collisions. Is that my understanding of like why storage layout is like something that we talk about when it comes to upgrades?
Yeah. So the idea being, like, once you've done that upgrade, you don't want to have any storage clashes where, like, a state variable, because essentially you separated out that logic and you kind of
Right.
removed some safety checks that Solidity has for
Okay.
memory storage because you've had to separate it. So there's a little bit of under the hood assembly that's matching things up. And you just don't want to be in a position where, because you've removed that safety check, you're now potentially overwriting storage or creating some very serious issues that can lead to just like bugs or even vulnerabilities for people to
Right.
exploit. So the tooling essentially will go in there and still automate that check before you deploy it,
Mhm.
since the Solidity code or Solidity compiler is not going to be able to do it for you.
Right. Okay, nice. See, this is why I love OpenZeppelin. You guys just do everything for me. And then I guess to the note of like the proxy pointing to the implementation contract. That also means that one implementation contract can serve multiple proxies, right?
Yes, there is a possibility to do that as well. I know we've noted it in a blog article that we made a few years back. So the idea being like you could have one implementation contract that multiple proxies are able to use,
Mhm.
and you can decide which immutable implementation that you decide to utilize. So that's certainly a possibility. You just need to make sure the proxies and the implementation contract are always compatible and aren't going to cause issues.
Right. Okay. Cool. So now that we've kind of established, hopefully everyone knows what a proxy is and what the implementation contract is. Um, maybe we can dive into the upgrade portion. So, because I think the proxy concept is like pretty straightforward, right? It's the issue of how the actual upgrade happens is what where the difficulties come into play, right?
Yeah, yeah, and I think it's really just around like what we were already talking about in terms of safety checks. Once you deploy that new implementation,
Mhm.
like the two biggest things are one is the access control for who can approve that secure, not just or do we trust the people doing it, but also are the controls we built in the only upgrade role function that will call and allow
Mhm.
us to set new implementation is that properly controlled to ensure that no attacker could come in and exploit it by upgrading it maliciously. And then, of course, are the governance controls secure? And there's one example of this with Beanstalk, for example. That was a
Mhm.
governance attack that happened a few months back. And the problem there was not the upgrade ability necessarily, but the
Right.
governance mechanism that controlled it. What they were able to do is there was like some mechanism by which if you could get a supermajority of the vote, like 2/3, you could instantly, it was normally a 7-day voting period, but you could instantly pass a proposal if you got a supermajority. So someone did a flash loan, borrowed a lot of money, pushed it through, and it was an upgrade that just said, "Give me all the money." That was essentially what it did. So because upgrades are open ended, you can't build in a check that says, "Oh, don't let upgrades of this type go through." Maybe you could, but likely it's not going to be feasible. Because so upgrades are like you could do potentially anything to change the contract, including, "Oh, give me all the money," or something else that would be obviously malicious. So because again, we've broken immutability for good reasons, but for reasons it's a powerful tool we do not want to put in the wrong hands. So that's really important. And then, of course, when we're doing the upgrade, we just need to make sure it's secure, it's not introducing a bug. Before we
Right.
got involved with Compound directly as a partner, Compound had a bug that went out last year in one of
Mm.
their upgrades that caused a lot of funds to be paid out accidentally. So that was something that got through. And then the upgrade itself must be secure. There was an issue with Audius a few weeks back where they were using our library, but they had overridden some features that had introduced a bug with the upgrade itself, and that had also allowed an attacker to come in and steal some funds. So, and which is again why we would say if you're either use the library as is, or if you're going to implement and override some things, be very, very cautious with that to ensure that you're not causing issues. In that case, it was actually, I think, a storage issue that came up.
Yeah. Okay. So I'm hoping that means because everyone has heard your expertise, anyone who's joined us today or later will never have an attack or a vulnerability. Fingers crossed. That's a requirement for attending this session. Um, I guess, I'm kind of curious what is the pattern that OpenZeppelin follows, right? Because you guys have a plugin that we'll be diving into um, later after, I guess, this conversation. So if you want to give
Yes,
some details on that.
can do. So we actually support two specific patterns.
Mhm.
They're both they both use proxies, but they're slightly different in the way that they implement it. So one is the transparent proxy pattern. So that is, I would say, pretty common. Most people end up using that one way or another. And it's just a way to very transparently be able to like upgrade implementations. And really and then we have UUPS, which I'm actually trying to look up the full name of that just so I remember. But the difference is typically where is the like upgrade logic, because like a transparent proxy has the upgrade and admin logic in the proxy itself, whereas with a UPS, the logic is actually going to be in the implementation. So there are just some details on where the upgrade functionality is actually contained. The advantage of UPS is that you could actually kind of upgrade the upgrade functionality, so to speak. Um, and so
Mhm.
and so that could be very important, even for example, fixing a bug in your upgrade implementation. So we offer both of those in our library. We offer our upgrades plugin within Truffle will support either one of them. In fact, there's, you would just say I'm using UPS or I'm using Transparent, depending on what library you've inherited from. So that's really one of the core differences. And there's also some gas considerations. I think UPS is a little bit more gas efficient in terms of how it's forwarding the calls.
Okay, cool. Yeah. I think I read a little bit about this in terms of gas, but I don't remember. It's online, guys. I will send out a link of where it talks about gas optimization because it is interesting, I think, as also kind of a factor of upgrade patterns as well. Maybe it's not as much of a problem because ETH is going down, so everything's going to be cheap again. I don't know.
We'll
But
see.
maybe to that point too, right? When we think about now multi-chain world, right? Like L1s, L2s does upgrade. How does like upgrade work in that case? Is it different or additional challenges? Um,
Gotcha. And I,
anything?
I'll send you a video from one of our engineers that can go into more detail on like transparent versus UPS and like gas savings. But to answer your question, like how do layer twos change it? It changes. I think some things don't change. But it's really just the complexity of where the control is located. So it applies to both rollups themselves and then contracts deployed on rollups. So, for example, if I am a great example, if you go to L2 Beats, which is a great website, they'll list out risks of like where are the biggest risks for rollups today. One of the biggest risks is actually upgradability. The
Mm.
rollup teams control upgrade roles on them, usually because they're new and they're in beta. And if there's a big bug that affects the rollup, they want to be able to deploy something to the layer one smart contract to change that. But you have to be aware that that is also a role that can be used to, upgrade the rollup in such a way that it might invalidate the security and trust of it. That I think most of the teams doing that are doing so responsibly. So no flack there, but it's just something to be aware of, and hopefully that will be decentralized over time once it's matured to a certain point. But then if you have a smart contract that's on a layer two, you also have to know, okay, what's the cross chain control? Is it a layer two smart contract that controls the upgradability? Or maybe we have a DAO that's on the layer one that's actually going to have to control the upgradability for the layer two smart contract, which requires cross chain calls. And there's actually a library we built into OpenZeppelin recently as well called cross chain, which just allows you to do modifier support for allow essentially cross-chain calls on like access control stuff that could also be applied to upgrade roles. So there's more complexity that can come from that. Like optimistic rollups have, what happens if something gets challenged on the layer two and how does it resolve on layer one? There's a lot of potential systemic complexity that comes from that. But in
Yeah.
terms of upgradability, I think the most important takeaways is just like, what is the rollup itself upgradable and how is that controlled? And then
Right.
for any smart contract deployed on the rollup, is there is the control located? Is it a layer one? If so, there's going to be some cross chain communication required.
Right. Okay. So I'm getting like two takeaways here is like number one, um, I need to bring on someone from L2 to talk about upgradability from them for sure. And then I guess the second piece is like upgrading is hard. I'm like, oh no. But I think before we close up, there's a few things I also want to touch. I think yesterday when we were talking about, you just offhandedly mentioned metamorphic contracts, which I had never heard of. So I was like, wow, this is so fancy. I'm like very enamored by the word metamorphic, but I don't know what that means at all. Yeah.
It's another approach that we haven't focused on as much, but there are some implementations by like Zero Age, who works
Mhm.
at OpenSea now, and he has basically this pattern of kind of using Create Two, which is a functionality for basically predicting where you're going to deploy a smart contract. And there's like a way where you could basically self-destruct a smart contract and then redeploy it with Create Two. That's essentially what the idea is. Um, it doesn't have a proxy and it doesn't require constructor changes, but there is a major drawback, which is it wipes out the state essentially. And so when you're
Mm,
redeploying it, you're going to have to figure out a way to either migrate over that state, um, or you're going to have some potentially downtime while you're waiting for it to be redeployed. So there's some limitations to that, but there might still be some use cases for it out there in terms of like maybe using that instead of a proxy. It's going to ultimately depend on the use case. I would say in general proxies are usually more applicable, but I'm sure there's going to be
Hmm.
scenarios where metamorphic could help. And the nice thing about metamorphic is it is a bit more, I guess you could say, um, state conscious in the sense that you can just wipe stuff and then redeploy instead of like redeploying the same logic slightly different over and over. But again,
Yeah.
I think there's definitely complexities that come in with Crate 2 and self destruct, and those are both very powerful opcodes that need to be used carefully as well.
Okay. Cool. Um, and then I guess going back to the question I asked at the front, where it's like, what if, like, we have to make this decision from the start? What are the ways to get, are there ways to get around this? Like, if I just was like, oh, whatever, I'm not going to handle this because whatever, you know what I mean?
Uh,
Um, Getting around it. Yeah.
um, I would say for the most part, it's just migrations are your only alternative. And like we've seen
Hmm.
this in the beginning, like before upgrades were a common pattern that people were using and
Right.
trusting. People had immutable tokens they were using, and if they felt the need to change it or add some functionality, usually they would just say, "We're going to migrate to a new token." And you have the ability to, using there's like a mechanism they built in where if you take your old tokens and you deposit it in the new token contract, we'll generate the new tokens and burn the old ones.
Hmm.
um, so that was usually like, so barely migrations is the one way around it, but usually people have done that only to move to an upgradable contract once they felt
Mm.
comfortable or the standard had become commonplace enough that they were confident enough to do so. You could do the opposite. You could say, okay, eventually we're going to get to the point where we're not going to make this upgradable. We're going to burn that,
Right.
and we're
Yeah.
fine to be immutable. So I would say it's usually better to start upgradable and then move to immutable if you
Hmm.
need upgradability. You don't
Right.
always, but I would say if you're not sure, it might be safer to have it than not need it.
Hmm. Okay, so does that mean every tutorial I put out from now on should just only start with upgradable
No,
contract?
I would say no, because the one thing is that it is a bit more complex. Like,
Mm, yeah.
you have to, use that upgrade plugin to deploy it
Right, yeah.
safely. So it does complicate the deployment process a bit. So I would say like
Mhm.
for R&D and experimentation, like,
Right,
not having upgradability is fine, especially if you're on test nets and stuff like that. It's only
right.
when you're deploying something that, a lot of people are going to depend on that you want to consider upgradability in the process.
Cool. Yeah, so I kind of wanted to this brought up the thought of last week. We were talking about rentable NFTs, right? So that's the newest standard that has come out. We were talking with one of the researchers from Double Protocol about, what happens. My NFT right now is not rentable. How do I rent it out? And he had mentioned something about like a wrapper contract. I don't know if you have any familiarity with like the security implications of a wrapper contract or like what it means to like wrap. Like, not that it is upgradability, but it is kind of upgradability in the sense that we are adding additional functionality, maybe.
Yeah, so I haven't read into that spec in detail, but like I
Hmm.
do know that the biggest issue with wrapping is just like enforcing it. So you can wrap, you can't stop people typically from wrapping.
Right, right.
So I think if it's again, I'm not too familiar with it, but if my general concept is it just wraps around an existing 721 and then allows that access to be more easily shared, that seems to make sense. I know someone
Right.
asked if it's going to be added to the OZ library. I'm not aware of any plans to add it, but we're an open source project. So if you add a PR to the project and say, hey, this is an EIP that we want to have, and it looks like it's been finalized, so it's a finalized EIP.
Right.
So if someone wants to add it to the library, our team would be happy to review it and potentially merge it in. I'll say we're obviously very picky because when people use our library, they make a lot of assumptions about security, but which we still have gotten a lot of good third-party contributions and add stuff in as much as we can. We've got 2 to 3 people working on the
Right.
library full time, so we try to get things in the backlog, especially if a lot of users are saying they want it.
Okay, cool. Yeah. That's super important because when you said about you guys care about your contracts, because anytime someone asks me like, Emily, how do I build a secure contract? I'm just like, I don't know, use an OpenZeppelin one. They're gonna it's really great. But yeah. So I guess, do you have any closing remarks before I ask you one final question about your background and then open it up to the audience?
I think, yeah, I mean, I said a lot of what I want people to take away. I guess the closing is that, yeah, upgradability is a tool. it has some complexity, but you can encapsulate that by using libraries and tooling from OpenZeppelin, as well as other places. But I am of course biased to our own tooling, and that's because, oh yeah, there is complexity in open upgrades that you need to be aware of. But just if you're using the libraries as intended and reading the docs, then you don't really have to worry about that. It's like no one can explain. Most people I know would not be able to explain how a hash function works, but they can still use a hash function. Like input goes out, output comes out. They understand that concept. That's the way you should see upgrades. Is like as long as you're using it as intended, you're not messing with the crypto. To use the hash function example, it should work just fine.
Okay, cool. And then I guess usually my question is like, oh, do you have recommendations for Web3? But given that you're a security guy, like that to me, I'm just like, do I need to get a PhD to get into security? What is like, how do you even know? I'm like, I can't even, I don't know. Yeah. I can't even
Yeah.
formulate the question because I don't even know how to get into security, right? Like, where do you
Yeah.
learn this knowledge?
It's so everyone has a different answer. I'll just say that. I would say
Right.
PhD is definitely not the typical path for a security professional.
Okay.
Because usually it's just being very hands-on and being willing to like just dig your hands into things and understand how they work. So like a hacker mindset is typically not like, oh, I'm going to break things because I'm mean and I want to hurt people. Or it's more like I want to understand how things work under the hood and play with it and tinker with it. So like just that's if you take that mindset and you just every time you go into a smart country, like how does this work, and you think about it from a threat modeling perspective, which is to say what are ways that this could go wrong. That's and you just go and you walk through different smart contracts that are public and you're like, how could this work? So getting started is just unfortunately going to be just going through a lot of different resources and finding your own path. But I would say the place where people start to really get good at it is learning what works for you know going through either bug bounty programs or just reading through code on their own and just trying to find bugs. It's going to be a hard slog at first. That's the thing. It's a grind to both like get the knowledge necessary to find bugs and then just find them because they can be rare because people are obviously trying to avoid having bugs in their code. And it's with public code, open source code, it's open season. Other people can also be looking and finding bugs before you. So it's almost like a little bit of a rat race in that case. I will go ahead and take that opportunity to plug that we do have a security fellowship at OpenZeppelin. So we are basically saying if you still should have some technical experience and Solidity or other backgrounds. But if you're like, hey, I want to learn security specifically on Ethereum, we do have a program that we release where you can essentially sign up. You can kind of do a pseudo internship, and if you do well, you could even join the team. So that's one path for people that aren't security professionals yet but might want to become one.
Okay, cool. Then that's awesome. Bug bounty programs also exist at Consensus, so keep an eye out for that. Monies, right? But let's dive into the questions now. So I'll just go ahead and bring them on screen. You touched on this. I guess OpenZeppelin doesn't have one yet, but open source is the backbone of Web3. Truffle is also an open source project, so if you guys want anything to get done, you can also do it yourself. So, yeah. Um, I guess the next piece was here. You kind of touched upon it, but I don't know if you want to go into more detail.
Yeah, I've been skipping ahead. So yeah, explaining the benefits or drawbacks of UUPS and transparent. So yeah, it's just where's the upgrade logic located? In transparent, it's in the proxy, and UUPS, it's in the UPS. So do you want to be able to upgrade your upgrade logic? And then also gas optimization. UUPS can be a little bit more gas efficient. But I would say that the advantage to transparent is just the fact that it's a little bit more commonplace, maybe more mature by comparison. But we support both. We would recommend both for most people. So ultimately, it comes down to you. And there's articles that OpenZeppelin has that will explain that more detail. The video that was linked is going to get into that more detail than I could.
Cool. Um, there's this one. Are they? I'm not sure if this is an Open
Uh,
Zeppelin question.
an Ethereum question, yeah, it's an
Yeah.
open one. So yes, that's in the roadmap to deprecate self-destruct, and it's mainly just because I'm not a core developer, so I can't comment on the details. But from what I've heard, it just adds a lot of complications and overhead to running like client nodes to be able to destroy state, which is essentially what self-destruct does. So I guess if that would be one reason maybe not to consider metamorphic because that might not even be available in the future. But that's probably long down the roadmap. It's kind of in the what would you say? It's in the cleanup bucket of like, this is just stuff we're going to do after all the exciting stuff is done, or when
Yeah.
we just take a break to do cleanup on the code. But yeah, apparently that is a plan. By the way, also for the question on 4907 for the rental NFT standard, I just looked through our library. There's no issue or pull request on the contracts repo today that's talking about that. But if someone would be interested in filing that issue or even creating a contribution to a pull request, it's open season.
Cool. There's this one. Can you talk about the workflow? You can
Uh,
talk about it. I will also be demoing it, but if you want to give a sneak peek, I don't know.
yeah, I think what I'll say there is essentially the workflow is that there is a way to plug into Truffle. We have documentation that goes through that step by step. So I'm sure you'll basically be giving everyone a live demo. But the workflow is essentially once you're doing, ready to do deployment, you can run the tool, and you'll have tests that essentially are going to check, okay, when we deploy the proxy, is this safe? So when you're writing your deployment scripts, they can include an automatic check essentially to say, before you do the upgrade, is it safe? And so there's a OpenZeppelin truffle upgrade that you can specifically use for that.
Okay. I don't know if there's any more questions. If not, I have one personally for me because I was also digging around OpenZeppelin issues and forums. And so getting back into the upgradability is something you have to think about from the start. You had touched upon something that is necessary is that we don't have a constructor, but right now the OpenZeppelin like base contracts, so like ERC20, like whatever 721 all start with a constructor. Is there like a do we need to modify those on our own or like because yeah, I mean like we talk about constructors and then I'll also go into the initializable contract that OpenZeppelin provides, but I don't know if you have any.
Yes, that's a good question because of course we don't want people to have to modify the base contracts if it's not necessary. So we
Mhm.
try to avoid that. So we actually have a separate repo that is entirely upgradable. So we actually have a transpiler. So it just takes the code from the open source, the regular OpenZeppelin library where there's constructors, and then it just changes them all to be upgradable. It removes the constructor and adds initializable functionality. So and then that would obviously work very closely with our plugin as well if you wanted to confirm the upgrades are safe. So yeah, so I think practically all of the contracts we have in our normal library are also present in the upgradable library with the changes that are necessary to be able to do those upgrades safely. And then our docs would fill in the rest in terms of how you do that through Truffle.
Okay, cool. So that's everything I have. I'm gonna jump into actually upgrading a contract, I guess, with whoever is still around. Feel free to stay on. Feel free to also take the rest of your day to do work. Maybe implement the rentable NFT. I don't know.
It won't be me. I wish I had time to do that, but there are smarter people than me that can write it. But yeah, what I'll do, I've got to hop on a call after this, but it was a pleasure. And if anyone has questions or comments for OpenZeppelin, and again, especially if they want to make contributions to any of our tooling or contracts, feel free to reach out.
Okay, cool. Oh, yeah, I guess the last piece, is there a way to get in contact with you if they want to get more information, or maybe you don't want to open up your
Uh,
personal stuff to the
I'll, I'll put
entire
my
world?
I'll put my Twitter out there, so people are more than welcome to tweet at me or DM me. And for the rest of the team, we also have like the forums where you can always ask questions, and then same for the GitHub repos. So you can always go to the GitHub repo directly, file an issue for something that you might want a specific tool, and then we'll get in contact from there.
Okay, awesome. Thank you so much for taking the time to join. Um, I guess this will be a goodbye, and then we'll jump into the actual coding.
All
So
right,
cool.
it was a
See ya.
pleasure.
Yeah,
Talk to you later.
bye. Okay, cool. So for those of you who are still on, let's actually go through how to use the OpenZeppelin plugin. I will start by sharing my screen so you can watch me crash and burn as I always do whenever I'm live coding. Standard screen, we're going to be using Truffle today, as well as Ganesh, our local test instance. If you want to be deploying to testnet, mainnet, you will need an Infura account as well as MetaMask. I will be doing this through the VS Code extension. As always, I mention this every week. I don't know if I need to stop mentioning this. Test ETH. I use Paradigm. Someone did message me saying that Paradigm faucet requires at least 15 Twitter followers. I linked in the guide for this, I guess, talk that will be coming out later today, 2 other faucets for girly ETH that don't require the Twitter followers. So wait on that. But obviously, crypto Twitter is alive and well. If you want the latest alpha, you got to join. So let's get started. Let me open up. First thing we always need to do is we're going to start a fresh Truffle project. So let's call this upgrade. Cool. And we're going to create our first contract. Upgradable pet. Oh, I do this every time. Okay, here we go. Create contract upgradable pet. Let's create a test upgradable pet. Cool. Now let's open up our code. And let's see what's in here. So we have our upgradable pet contract. Migrations is where we're going to tell I guess Truffle how to deploy using OpenZeppelin's deploy plugin. Test is where we're going to test this. Note that when you're doing upgradable contract writing, you should be writing a test for both your logic contract, so that's your implementation contract where the actual code is happening, as well as the proxy contract. So ensuring that that state is maintained as you change out the implementation. We'll dive into how to do that, but let's actually start with just kind of our base V1 version of the contract. So start from the beginning. This is going to be super simple. So I'm just going to have upgradable pet basically be a contract that will store a value and retrieve the value. So in order to do that, let's just say 256. Here's the value. We want it to emit an event anytime the value is changed. So it'll take you into 56 value. Oh, whoops, not emit, sorry, event. We're defining the variables. Cool. And then there are 2 functions, store and retrieve. So function store is going to take a value public and basically just say value equals value and then an emit event value. Cool. And then the last piece is to actually test that it was properly stored. So public view returns, it's going to return that value. So uint 256. And I'm going to return value. Cool. Now, there's 2 things that Mike had touched upon in terms of making it upgradable, right? So the first part was we don't want a constructor. Rather, we are going to use something called initializable, which is a base contract that OpenZeppelin provides that allows us to kind of fake the constructor with, I guess, their provided checks in place. I'll go ahead and do it, and then we'll dive into the contract so it makes a little bit more sense. So that's just going to be importing their upgradable, initializable, what do you call it? Contract. We need to install actually that OpenZeppelin library. So npm I at OpenZeppelin /contracts -upgradable. And as we wait for that, it is just going to be an import. Hopefully everything works. I'm really scared. Okay, cool. Initializable. What is it called? I'll just go ahead and copy paste this guy. Cool. Why is it not being able to file import? Not. Did I not import it correctly? Let me try again. No, if this doesn't work, then I can't move forward, and you'll just have to watch me debug npm for like, is it in my node modules? Oh, wait, why is it not? Oh, because I'm, where is it going? Okay. No. Truffle upgrades requires a peer of. I not have truffle installed? I definitely do. Guys, I have truffle. I've been using truffle. 5.5.27. Oh, where is it? Where did my terminal go? How do I use this? Oh. Well, let's just pretend this is working. I'm sure it will. We'll just go ahead and write what we're expecting here before we move forward. So here's the import statement. Is initializable. Cool. And then what this is going to do, okay. Let's see if this is going to work. No, weird. Okay, you know what, guys? I don't know what's going on here. I'm just going to open up a version that actually works, and we'll move forward with that. I'm so sorry. I don't know what's going on, but that's fine. CD. Was it because I'm in the wrong folder? Oh, wait, what? Where am I? Oh, okay. This is why I opened it up in a weird, I didn't open up in a clean folder actually. So, I think if I do this, where is it? Oh, it's right here. Okay. Maybe this will work if I move Unleashed upgrade contract, upgrade up one to here. Okay. Whoops. Let's save. Hey, isn't the point of a live stream so I can make these mistakes and you can see like, oh, Emily, don't open your contracts in the wrong area. Okay, npm I. Oh God, if this doesn't work, I'm gonna cry. And then we'll just do it with a copy that I know for sure works. Nice, haha, guys, success, amazing. We did this together. Okay, cool. So it properly imported. Here it is initializable. Let's just dive into this really fast. So a brief explanation of this contract is essentially, this is a built-in, a base contract that OpenZeppelin provides that allows us to use a regular function, so not a constructor to, I guess, initialize your contracts. There is one thing that they note here. It is a security issue if you forget to initialize your contract. One suggestion that they have here is actually to include include a constructor so that you will always be like the constructor. Always include the constructor to the extent that you won't get into a state where the contract is uninitialized because you forgot the initializer. But also to kind of have that caveat, you need to make sure that you are not ever calling this multiple times. So that's why they recommend this piece. So dive back into the actual code. We will be needing to add that initialize function. So it's a function initialize add public initializer. And this is just a modifier to get this function to do all the things that it needs to do according to the base contract. This isn't necessary. I do want to demonstrate what it looks like to add a parameter to the initializer. So let's just pretend like we want to know who the owner of this pet is. I'm just going to go ahead and add another field called private pet owner. And then it's just a simple pet owner equals pet owner. And then, as I said before, right here, you need to add in this piece just as a safety precaution. Specifically here, you'll notice that they include this little comment thing. If you remember from Mike's talk, basically with OpenZeppelin, they do a bunch of checks using the plugin to make sure that things are safe. And if you want to kind of override any of those checks, they have, I guess, this kind of syntax to do so. So, anyways, next thing I just want to call out is upgradable pet right here is just like fine. Say it was inheriting other contracts, because initialize is a regular function. It's not gonna know to initialize the previous functions. So to compare against maybe let's say like contracts. Inheriting previous contracts using constructor, Ethereum just naturally understands it needs to go back up and do all those, call those constructors. However, in this case, initialize is not a special function like constructor, so that is something you will need to think about if you are writing a more complex contract. Then the next piece is actually let's deploy this contract. So I'm going to delete these things because you don't need them. Let's create a new file, and we're going to call this our deploy contracts file. Cool. And I'm just going to write it as if it wasn't an upgradable contract at first, and then we'll see what it actually looks like when you want to. So upgradable pet equals artifacts dot require upgradable pet. Cool. And then module exports equals async function deployer. And then we will do, normally it'd be like a deployer.deploy. However, this time we are using the OpenZeppelin plugin. So to do that, we also need to download it. I'm calling it save dev because this is a development dependency. You don't need to commit this into production. Truffle upgrades. So this is the deploy upgrade version for Truffle. If you are using Hardhat, OpenZeppelin also has a separate one for that. The process is a little bit different, obviously, since we're on I guess I'm the Truffle developer advocate. We will be using the Truffle plugin. I'm going to go ahead and start writing what we're expecting. So we're going to be using a function called deploy proxy. And that will just be retrieved from this package that we just imported. Cool. And then all you need to do is deploy a proxy. Upgradable pet is the thing that we're deploying. I wanted to show you guys what it would look like if we had a parameter we passed into the initialize. So that's going to be, I'm just going to say it's the first account. If you want to modify, get account numbers from the deploy file, you can actually add these additional features. And that would just be 0. Pass in the deployer. And then you need to tell it what the initializer is. So the initializer, initializable contract, base contract gives you a default initializer. So actually you don't need to call this at all. But I'm just doing that to show you. If, for example, you wanted to call your initializer function something else, I don't know what you would call it, like start or something, and define it that way, then you would just say, hey, this is actually the function that I want to use to initialize my contract. But that is all done. So in order to get this started, you could write a test. I'm actually just going to show you guys how to do this kind of stuff on the fly. So in order to do that, we need to start a Ganache instance. I'm just going to start it from here, 8545. And then now that that's started, we need to go to our truffle config. And then comment out the development network to indicate that we want to use a separate Ganache instance. So I haven't mentioned this before, and I think it's a common misconception that you do need to start a separate Ganache instance. You actually don't need to. Truffle will do that like organically if you run like a truffle test, for example, so long as this is commented out. I just prefer having a separate one so that I kind of just always have the Ganache information. So actually need to start it and it should show up here and you have all that information. Cool. So now we can actually start interacting with it directly. Truffle console is going to open up a console and then we're just going to migrate it. We're going to hit migrate. And if it all works, you'll notice that the OpenZeppelin plugin actually deployed 3 contracts, right? So our implementation project contract, a proxy contract, and then proxy admin. So this is a third contract, which basically is the person who can control whether or not we are updating the proxy. So I think this is what Mike had also been touching upon when he was talking about gas costs with UUPS versus transparent proxy, is because you have this kind of like third thing to call through that requires a little bit more gas. But yeah, I think the next piece then is just to quickly see whether or not store and retrieve work, right? So let's just say let v1 equal await upgradable pet dot deployed. Cool. And then we're just going to do a v1 dot retrieve. I'm actually going to do it this way so we can get the 2 number. So the default for a uint is going to be a 0. So we should be expecting 0. And now if we do an await v1 dot store 5, and then do this again, 5. Okay, cool. So that works. Let's actually get to the part where we do the upgrade portion. So that's pretty exciting. What we're going to do is basically duplicate this. So copy, paste, call this v2. So this contract is going to be exactly the same, except we want to add an increment function. So that's going to be a function increment public value equals value plus 1. And then again, emitting a value changed that happened. Here we go. Cool. So now that that's done, basically now the next step is we want to deploy this again. If we want to do kind of all that magic of upgrading the proxy address, implementation contract address for the proxy, this is where OpenZeppelin comes in again. So we can just assume this is like way down the future, and actually we are doing upgradable pet v2. So in order to do that, the same idea, v2, instead of deploy proxy, we'll be using upgrade proxy. Upgrade proxy. And then the parameters here are basically we need to send in the proxy address so we know what to update, the new contract that we'll be using. And then again, Truffle needs the deployer to deploy. Cool. It doesn't know what proxy is. That's actually going to be our previous upgradable pet address that we got. So proxy equals upgradable pet dot, sorry, we needed to wait. Upgradable pet dot deployed. It is already deployed. And if you remember when I said before, the default for deployer is going to be initializer, so we didn't need to specify that there. So now, if we just call migrate, it should work. Why didn't it work? Oh, wait, what? Dang it. What did I do wrong? Did I spell everything correctly? Oh, I didn't. Okay, that's why. Here we go. I think now everything is spelled correctly. Nope, something is still not spelled correctly. Is it this one? Guys, upgradable is so hard to write. Why did I call it this? Yep, see, exactly. I spelled upgradable wrong again. Okay. Now it should migrate, please. I put the correct, oh gosh, darn it. Okay, you know what? I'm just gonna copy paste the code because I don't know what I misspelled here. Oh, is it something wrong? What's going on here? Deploy contracts. Could not find artifacts for upgradable pet v2. Was it because I spelled this one wrong too? No, is everything spelled incorrectly? Oh, there we go. That's why. Let's just make sure that that is correct. Okay. Okay, nice. See, we make mistakes together. Don't do what I did. It is here. So now what is important is we need to make sure that that state was preserved. So before we were storing 5, we should expect 5 again. So in order to do that, so v1.address we still have, that's the proxy address. Basically now we want to get that v2 contract. So we're just going to call it const v2 equals await. And so in this case, I'm just gonna copy paste, here we go, dot add. So this is a truffle like special thing where basically if you do the contract dot add, it will get that contract abstraction wrapped around an address. So we care about referencing this proxy address. So that's why we're gonna do contract dot, dang it, v1, sorry. There we go. So now, if everything works, fingers crossed, we should be expecting a 5 retrieve dot to number. Cool. Storage is properly set. So also now we have this increment function. And if we retrieve it again, it is 6. Totally expected. That is our upgrade path. I said I was going to have time to write tests. We are 20 minutes over time. I don't know if people want to stay on or if there are still people on. I'll just go ahead and keep going. I don't know if I have any other work meetings after this, but that's fine. I'll just skip all of them because you guys are more important. Let's write tests. So like I said, there's 2 things that we need to care about when writing tests with upgrades is we need one for the implementation contract as well as doing the proxy contract. So let's go into tests. We're just going to write one for the base contract. This is actually probably bad practice, guys. I should have written the upgradable pet v1 first and the test first and tested all of that first before doing the upgrade. Obviously, I didn't. Don't follow what I did. Just gonna copy and paste the code again so that for time's sake, but step through it. If you guys are familiar with our tests that we've written before, super simple. Again, I'm using OpenZeppelin's test helpers to basically do the check of the revert and the expect event. So that's going to be specifically here, expecting that the value changed. And then in the revert case, oh, I forgot to add this. Sorry. I actually wanted to add a require, basically saying that only the owner can store the change. So I'm also just going to copy paste that code because that's a lot of text. Cool. And then same thing here. That was just like a flavoring thing I did to make the contract more complex. Obviously not necessary. Do what you want for your own contract. But yeah, so using this to essentially make it easier for us to let's do this. Retrieve the values, or sorry, do this expecting event and expecting the revert, which is when the upgrade fails. So I'm just gonna, that should pass, hopefully. But let's create a new one. Again, except let's call this one dot proxy JS. And I'm just gonna copy paste code here again. And show you what the difference is here. So it's effectively the same because that proxy should be calling into the implementation contract. But to make sure that we are using the proxy contract, you can actually use the deploy proxy function defined by Truffle upgrades here in your test. And hopefully this should work. I think it might. Yes. Okay, cool. So that would be your first thing. And I'm like, wow, now it's work. And then I would do the upgrade pattern v2 and create the test. I'm just going to create the test from here. Upgradable pet v2 test. Cool. I think it was this one. Yep. And same thing here. So I'm just going to test the increment portion of it. As you notice, we're starting from like the base. This is just like the implementation contract. So there's no preservation of state that we're testing. But if we're doing the proxy version of it, so let me just copy paste that. Proxy. And go into here and test it. The difference with the proxy contract, again, is we are using that upgrade proxy from OpenZeppelin to be interacting with it. So it's kind of like the same idea that we had done through Truffle Console, was we deploy the v1, modify it, so we modify the storage, and then actually do the upgrade portion and validate that that storage was preserved and now we can increment. So, I mean, Truffle test, I'm just running all the tests at once. You can specify at a per test level if you want, but it all passes. And that is great and awesome. And that is all there is to, I guess, upgrading the plugin. Before I get questions, how do I stop sharing my screen? Here you go, stop sharing. I'm going to go back here. And Basically, if you guys are interested in getting any of the materials that blah, 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 Michael had talked about, notifications about what's going on in the future, please fill out this feedback form. I sent it in the YouTube chat, as well as I'll go ahead and send it in the Crowdcast chat as well. Please please fill this out. Definitely like stay in touch with our email list so that you can get notified. I'll go ahead. Actually, I will share my screen again so you can get that kind of information. Okay, cool. So this is the thanks portion. But yeah, so what's next? Next week, we won't be doing a Web3 Unleashed. We'll actually be pivoting over into our Truffle community call. So that's going to be focusing on our ECC hack winners. For those of you who are building and want to attend a hackathon, kind of tips and tricks for how to win the big money. And then also ChainSafe, if you guys don't know, are the maintainers of Web3.js, will be joining us as well. Also, for the beginners here who aren't familiar with Web3.js, that is kind of allows what your front end to connect to the blockchain to handle. And I highly recommend attending this one because we will be using Web3.js in our next stream, where we're actually going to build a full stack dApp. So if you've noticed, I've done a lot of smart contract only development, but from like the full end-to-end experience, we're going to be taking that rental NFT that we created in last week's session, and then actually seeing how that looks like in a marketplace with a front end using Web3.js from ChainSafe. Moving forward, we have one of the co-founders from Gelato, co-founder from LivePeer. And if you have extra things that you want to see, like again, please let us know. This is for you guys. Never really a set plan. It's kind of whatever I feel like, whoever talks to me. Oh, and then the other thing to note actually is starting, I guess, not after the community call, we will be changing the time for these streams from Fridays at 9 a.m. PST over to Thursdays at 9 a.m. PST, since that seems to be a little bit better for, I guess, other people. If you don't like that time change, also please leave that feedback as well. Very flexible, but I think that's everything. Again, thanks so much, guys. Links to, follow me on Twitter, follow Truffle. Sweet. Get me on LinkedIn. Feedback form, again, email us, let us know what you want. If you want the, I guess, learning materials covered here today. But yeah, I don't know if there were any other questions. I kind of just jumped into this, but if not, then we can end here. Let me stop screen sharing. I don't think there are any more questions. So thanks, guys. I know I always say this is 1 hour, but we've been going over. But I guess that's because our guest speakers have been so great. So yeah, have a great day. Upgrade your contracts, and stay secure. Okay, bye.